Our next three talks are from distinguished alumni of our department, showcasing some different paths that people have taken after working here. And first, I'm really pleased to say that we've got Dr. Alice Bunn, who actually did her PhD here with Lindsay, our previous speaker, when she was here. She's the CEO of Appoint of the Institute of Mechanical Engineers, and she's currently the International Director at the UK Space Agency. And she's responsible for increasing the UK's global influence in science, security and trade through space. And she's going to tell us more about that now. So over to you, Alex.
Thank you very much indeed, Ruth. Thank you. You were very kind, not to mention when I was actually doing my PhD with Lindsay, which was quite a while ago now. So I was at Darwin College and studying in the department between 95 and 98, doing a PhD on grain refinement in aluminium alloys. And, it's funny, I get taken back to that PhD quite regularly in the current job. So what is the current job? Thank you for the introduction. International Director at the UK Space Agency. That in practice means that I've got responsibility for forging UK relationships in space, be they to achieve science objectives, be they more to support commercial growth, or increasingly to support national security. And it's fair to say that there is an absolutely remarkable history of international cooperation in space. And why wouldn't you? So to start us off, I thought I would take us all the way back, really to the 60s, to the Apollo era. Casting your mind back to that time, obviously this was one of the, if you like, fiercest fought science and engineering competitions that there has ever been, really, between the US and Russia at the time. At the height of the Cold War, a real race to the moon, but actually a real race for supremacy, for national prestige. So it's quite difficult to imagine that there was very much cooperation going on at the time. And although at the political level, there was certainly very little, at the technical level, there absolutely did endure that cooperation. So thinking back to about 1968, it was around about Apollo 8. There were actually two missions going around the moon at the same time, one containing US astronauts and the other, as you see here, little known fact, containing some Russian tortoises. So the operations teams of those two missions had to coordinate quite carefully to make sure that there was no interference between signals and indeed no interference between the missions at all. So it's quite extraordinary, I think, that even at that fiercest fought competition, there was still this cooperation going on in space. And I think even more remarkably still, a decade later, so cast your mind back then to the 70s, so really at the height of the Cold War, there was a new international cooperation in space, which spanned the US, Russia, China, Japan, and Europe. And I find that absolutely incredible. So these incredibly sensitive space technologies at the height of the Cold War, and yet there was a partnership between Russia, US, China, Japan and Europe. And what was that partnership on? Well, really, that partnership was laying the scientific foundations, the framework, if you like, for the first global meteorological system, providing weather forecasting. Now, today, over 99% of the data that we need to generate accurate weather forecasts come from space. And it is true that you really need a global endeavour, a global partnership to get the right data to enable the accuracy of those forecasts. And, moving on from there, you can see on this slide, this really is illustrating it's a number of objects, but you could use that as a proxy for the number of actors, the number of missions going on in space. And whereas you look back to that 60s and 70s period, and there was really very few, now, given that realization of the power of space, so weather forecasting being a really, really good early example, but now we see applications across a range of different types of services, if you like, that we can bring back to the benefit of people on Earth. You see this great increase in the number of missions the number of different countries having space programs, and the number of different, in particular, commercial space programs. You may be able to see on this slide, the one part of the legend that I find absolutely terrifying is the red part, which is labelled amateur. I think this was taken from a piece of research in the US. I think probably we would more politely call them new entrants rather than amateur operators of space programs. So what type of applications am I really talking about? Because it's true that most of us, when we think about space, we think about rockets and astronauts and missions to Mars and missions to the moon and, daring do. And of course, space is that. But the vast majority of our space programs aren't necessarily about looking out into space. They're actually using that unique vantage point of space to look back down on Earth. So some of the programs that we've got running at the moment are absolutely transformational in terms of enabling activity back on Earth. We run a fantastic program, again, an international partnership, a partnership between the UK and developing countries. Now, that's quite surprising to most. It's quite surprising to make that connection between space programs and aid. For some people, that doesn't feel like they should be natural partners, as it were. But the types of programs I'm talking about are not missions to Mars. They are more about communications, for instance, enabling remote healthcare, telemedicine, enabling remote education, something that we've all become quite used to, I think, in these COVID times. So what we're seeing is a really interesting trend where you see in some developing countries, they're sort of leapfrogging the copper wire generation and going straight to satellites for their communication needs. Similarly, for navigation services. So we know that, for instance, every financial transaction we make has to have a precise timestamping, and that precise timestamping comes from the atomic clocks in space. So that's really underpinning the financial sector. It's one of the reasons why a recent report looking into what would happen if we lost navigation capability estimated that in the UK alone, just the UK, if we lost navigation capability, we would suffer economic losses of £5 billion over 5 days. So really an incredible benefit being delivered back to Earth from space. One of the most powerful international partnerships in space, I was privileged enough to be involved in this a number of years ago, and I'm very, very proud of that contribution, is something called the International Charter for Disasters. That was set up by a bunch of space agencies back around 1999, and it was really recognising the tremendous power of space capability in the immediate aftermath of an emergency. Now, it might seem surprising that you have that necessity for international partnerships when you're looking at a national disaster response, and particularly if you think about the number of countries that actually have their own environmental monitoring from space capability anyway. But of course, in the immediate aftermath of a disaster, timeliness is really of the essence. You really, really need that snapshot of what is going on as soon as possible after disaster has struck to be able to understand which bridges are still intact, which roads are passable, to understand the extent of the devastation on ground. And often the only way that you could do that is through images from space. Now, it's very unlikely that your camera in space is going to be at the right place at the right time. And that's why we have this partnership across space agencies where they pool their resources to share that data in the immediate aftermath of any kind of natural emergency. This image was taken, if you recall, the tsunami in Japan about 10 years ago. A shocking event in itself, that tsunami, which then caused the problems with the nuclear reactor and really, really caused widespread devastation on the ground in Japan. The Japanese government, within the first hour had picked up the bat phone, if you like, to activate the charter. So there's very few organizations within any country that is able to trigger this charter. But the Japanese government were able to do that. And what you saw quickly were satellites being tasked to take imagery. This one was a fairly routine one, but the data itself was being processed at a university in the US. You can start to make out some of the ground infrastructure. If you look towards the top of this image, you can make out tennis courts, 4 tennis courts there, 5 in fact. And what you can also make out is the letters SOS, that very iconic, universal language for cry for help. And the people that were trapped in this vicinity had been able to carve out that message. And it just so happened that the person processing the data in a university in the US picked that up, was able to alert the rescue agencies on the ground in Japan, and they were able to divert efforts towards this location to save some people who would have otherwise remained trapped. So, I mean, I find that quite a chilling image, but it certainly speaks volumes of the power of space to support, our lives here on Earth. So, because of this real power and real asset that space can bring to lives on Earth, we've seen quite an interesting institutional landscape emerge in Europe. So in 1975, we had the establishment of the European Space Agency. Really, that was in recognition of the fact that often space infrastructure is pretty large. You think about something like the International Space Station, it's about the size of a football pitch. It costs over $100 billion. So it's unlikely that any single country is going to be able to cover all those costs. So the European Space Agency really recognised that there was a very solid argument for countries to come together to pool their funding and to pool their technical expertise on space programmes. And the European Space Agency still thrives. In 1986, we had the formation of the European organisation responsible for the exploitation of meteorological satellites. So building on that very unlikely international partnership in the 70s, we had the cementing, if you like, of our operational weather forecasting capability through EUMETSAT in 1986. Here's where it starts to get interesting for the UK at the moment. So in 1998, we first started hearing about something called the Global Monitoring for Environment and Security Programme. This was an EU programme, a series of satellites looking down at Earth, doing environmental monitoring. And in 2014, this became known as the Copernicus programme. We now have a number of missions flying. And also at the beginning, just the turn of the year 2000, we started hearing about the programme called Galileo, which is a satellite navigation programme. Now, of course, all the benefits that I've described in terms of the support to the financial sector, the enabling of smart logistics, of, delivering packages, again, something we've all got very familiar with during lockdown. All of that capability that one might use in a civil context also has defence utility. So put very coarsely, that same navigation capability that enables safer landing of aircraft, precision logistics, is also the same capability that one might need for precision targeting of weapons. So it became quite sensitive. And Brexit, I've become used to, looking at my clock when I talk to see how long it takes me to say the Brexit word. But Brexit really forced the UK to take a very forensic look at the way in which our national security depends on space programmes. And as a result of that, the UK and the EU decided to go our separate ways as concerns satellite navigation capability. So we're no longer part of the Galileo programme. We intend to remain cooperating as part of the Copernicus programme. That environmental monitoring programme tends to be less sensitive. It tends to be easier to align ourselves behind goals around the environment, around climate change, for instance. And then there are other EU space programmes around secure communications and surveying of the operating environment, where again, we will go our separate ways due to those security implications and the defence utility there. But meanwhile, we do see an absolute unprecedented level of ambition for space in the UK. So we've had the establishment of the National Space Council, which is chaired at the very highest level by the Prime Minister himself. We have a new space strategy coming out this summer. And there have been a range of quite brave investments made by the UK recently. So notably the investment in the OneWeb satellite communication system last summer, where the government took a $500 million equity stake because they recognised the geopolitical significance of having access to a platform in low Earth orbit. They recognise that, if you want to be, to coin the phrase, a science superpower, you need to have a space capability. If we want to protect our national security, we need to have a space capability. If we want to project global influence, we need to have a space capability. And, the signs are good. We have punched above our weight in a number of areas so far. So although our investment is relatively modest compared to our nearest competitors, there are areas where we can truly say we have globally leading capability, in particular around space science, but also around the manufacture of small satellites. So only 20 years ago or so, there was a huge satellite, MPSat, again, an environmental monitoring satellite that was launched. It was about the size of a double-decker bus. Nowadays, it's quite common to see satellites launched that are about the size of a shoebox. So having that global lead in small satellite technology has been really, really powerful for the UK. I think there'll always be an argument for the bigger infrastructures too, particularly when it comes to some of those big science missions. And I think there'll always be an argument for big international collaborations. My analogy always here is CERN. It wouldn't make sense for any individual European nation to build CERN. In the same sense, it wouldn't make sense for any individual nation to build the James Webb Space Telescope, for instance, the successor to Hubble that will be launched at the end of this year. So there will always be that platform for large-scale international collaboration. But increasingly, particularly as we seek geopolitical advantage, I do think we'll see more and more national capability being developed. So what sort of things are we really looking at? Well, one area that's really interesting at the moment is something that people refer to as the low Earth orbit economy. So that's in recognition of the fact that around that low Earth orbit, we're seeing more and more different type of missions which deliver those benefits back to Earth. So a few years ago, our communications capability was largely in big satellites out at geostationary orbit. Now we're seeing constellations of satellites in low Earth orbit. Why? Because you can get that global coverage through the constellation, but also you get very low latency, so very, very small signal delay. So you can use that for, gaming, for live applications in a way that's more difficult from geostationary orbit just because of that time delay. We're also starting to see manufacturing in space. And this is where I think it gets very, very interesting from a material science point of view. So I was fortunate enough to have an experiment flown in space way back when, over 20 years ago now. That's because the particular thing that I was studying was being obscured by some settling effects. So the same experiment run in space would remove the settling and enable me to have a different perspective. Now we're seeing lots and lots more material science experiments being flown in space. There's a real shuttle service, if you like, back and forth to the International Space Station. The International Space Station is really, one of the world's biggest laboratories. It just happens to be flying around 400 kilometers above our heads. And we're seeing developments in the pharmaceuticals industry where they're able to produce drugs which have more potent characteristics when they're produced in space compared to a production back on Earth. For the first time, we're seeing fiber optic cable being manufactured in space. It has very, very low loss. And it's extraordinary to think that has now become economically viable. So the costs of going up to space and producing the fiber optic cable are worth it when it comes to the sales that will be realized from that fiber optic cable. So when we move from that transition between research, and it largely is in the research domain at the moment, through to manufacturing, I think we will start to see a real step change in the way that we use the space environment. Really exciting for material science, but really exciting for industry too. So, looking forwards, who knows where we will go with the UK in space? It's a very, very exciting time for space. There are lots and lots of different opportunities out there. I maintain that we will still thrive in our international partnerships, but I do think we will want to do more nationally, and I do think particularly we will want to do more to take advantage of those opportunities from the low Earth orbit environment and make sure that the greatest rewards from our space programs actually are delivered back here on Earth. I will conclude there, but I'm very, very happy to take any questions, and I think I will be handing back to Ruth.
Fantastic. Thank you so much, Alice. That is really, really inspiring stuff. So a reminder to everybody again to type your questions into the chat. We've got one already from John Wood, who says, thank you very much. And he says, in retrospect, was it good for the UK not to be involved in the International Space Station from the start?
Oh, that's a really good question. In retrospect, was it a good idea not to be involved from the start? I think what we observe is a very, very strong academic participation in the International Space Station. But because of the decision not to take part in those early stages, the industrial participation in the International Space Station is relatively low. So I think if you were an economist looking at that, you probably would say, yes, it was a good decision not to be involved from the beginning, because our value for money has really come from the wealth of academic research that we've had from the station. You could also argue, however, that it has slightly limited our ability to take part in the next big exploration programs. Mm-hmm. So the Artemis program led by NASA, seeing us return to the moon, and from there to use that as a base going onwards to Mars. So I think from an economic perspective, definitely the answer is yes. If you were in industry, you might have argued that actually if we'd have been involved earlier on, we would have had a bigger role to play in these future exploration programs.
Thank you. Yes, interesting stuff. So Rod Banstone says, how will we deal with the problem of orbiting debris?
Yeah, wow. I've got a very well-informed audience. The problem of orbiting debris is extreme, actually. There are hundreds and millions of pieces of debris flying around. You see it all the time. You see some horrific kind of first-hand photos taken by astronauts on the International Space Station where they see the damage being done by debris hitting the space station. I think on the positive side, we are starting to see capability now to remove debris from space. So even in the UK, actually, we had the ELSA-D mission launched a couple of months ago. So that is designed to remove debris from space. The difficulty, I guess, is commercially incentivizing that activity to happen, because what you are generally doing is removing large bodies from the past. So very often bits of rocket fairing that were launched, from Russian missions or Chinese missions. There was a topical one in the news recently, many years ago. So incentivizing that debris removal is a real challenge. We're starting to get attention on it, though. So at the recent G7 summit, we had all the political leaders there sign up to a statement on space sustainability. So we are starting to get attention on it, but there's a lot to do there still.
Yes, that's really interesting. So William Lee is saying, what role do you envisage for nuclear in future planetary missions, and will it be communicated positively to the public?
Yeah, I think it should be. So nuclear, gosh, there is a real opportunity here for the UK. So at the moment, all space missions, when they're going far out into space, need at the minimum heat units to make sure that the mission doesn't just freeze up completely. So when you think about nuclear, I always think about initial stage heat units, then you can have batteries, and then you can go all the way through to propulsion if you're really looking at some of those deep space missions. At the moment, we're entirely reliant on the US and Russia for that capability. But there is an opportunity for the UK through the Americium material to make that in a much more sustainable way, actually, to get that capability in a much more environmental friendly way. It would rely on working quite closely with France. It's quite interesting at the moment. I'm not quite sure we're at the point in time where we're ready to make friends with France, but I really hope that comes soon. And when it does, there's a real strategic opportunity for Europe through the UK and France to be developing that capability and using it in the civil way for our space missions.
So one last question, which is mine, but you mentioned right at the beginning your materials degree here and how it sort of had a theme throughout your career. Would you like to comment further on that?
It's interesting when you come back to it, isn't it? Because my experiment was flown, as I say, over 20 years ago. For me, I wasn't really wowed by space at the time. I wasn't one of those kids that, stared out of her window at the stars at night and dreamed about space at all. It was a very, very practical thing. And actually, after I left Cambridge, I went on to work at the Science Museum. And there I spent a while working in the Space Gallery. And again, at the time, it was the big sort of cash cow of the museum because everyone wanted to come and see the Space Gallery. I was pretty nonplussed. It was a, good for the business, but that was as far as I was concerned. And it was only when I came across space in the context of environmental monitoring from space that I really, really got the bug and thought, wow, this is something that is really, really useful. And I think we've almost come full circle now because I see there's so much more opportunity now through having material science in space and shifting from research to manufacturing that I've been able to credibly, if you like, refer back to my PhD experiment and be able to have the conversations that I've needed to have with the scientists and engineers of today to understand how we really capitalise on that opportunity in space.
Fantastic. Well, thank you very, very much, Alice. That was an amazing talk and some really interesting answers to questions there too.